Hi, my name's Doug Sparks. I'm the president of M2M Technology, and I'm happy to be talking to you at this conference about automotive sensor trends, what's new in ADAS and autonomous vehicles. SAE has a number of levels for vehicle automation. Your level 0, level 1 is what we're probably most familiar with. Virtually no interference from the vehicle, maybe some driver assistance such as adaptive cruise control or speed and steering controls. As you move up to level 3, you're starting to see eye monitoring being employed. 4 and 5, you've got a huge suite of sensors that enables driverless robotaxi applications. Now, one of the most noticeable trend that you see with autonomous vehicles is the increase in sensors per vehicle as you go up the numerical level. The typical private cars right now will have an IMU, maybe some CMOS imaging cameras for reverse, and then some ultrasonic sensors to prevent collisions or backing, parking incidents. Now, when you get into level 4, you're going to see more sensors. You're going to see things like radar and LiDAR being implemented. Level 5, you're going to get a total surrounding sensors looking at all different angles and orientations, front, back, side, bumpers. You're going to have multiple LiDAR, multiple radar sensors, and a large number of CMOS imaging sensors. One thing that's really become apparent recently is how electric vehicles has driven this trend. And it's driven a lot of sensor trends in the automotive industry. So you're going to see just an explosion of sensors as the L3 vehicles come online. And that's kind of what I highlighted here in blue when you look at level 0 through 5, which is robotaxi. You're going to see with level 3 a 68% increase in the number of sensors per vehicle, sensing and computing systems that are related to that. And for robotaxi, it's over 100% increase in sensors over where we're currently at. So as we go up this level, this is just another numerical example of how the sensor content's going to explode. And here's, if you look at the cameras that we call, seeing cameras, you've got your cameras, your CMOS imaging cameras, you've got radar, you've got LiDAR. As I already mentioned, CMOS imaging is already firmly entrenched. Radar is increasing with semi-autonomous vehicles. And then the trend that has been predicted here is that by 2027, LiDAR is going to grow explosively, and that again is related to both electric vehicles and the L3, L4 adaptation of those sensors. Another interesting trend is seen in China. It's expected, because of their very robust electric vehicle market and the number of participants, that they're going to lead this L4 vehicle introduction and sensor deployment probably in the 2025 timeframe. So, look for the trend to move away from the US and Europe to China for leadership in autonomous vehicle sensing. And they really have, China really has a robust LiDAR supply chain. This just gives you an example of some of these things. And that's going to have a big impact. You've got to have the whole supply chain. You've got to have the photo detectors, the ICs, the LiDAR, the laser sources, optical electronics to implement LiDAR. And that again is going to be connected to the L4, L5 rollout around 2025 to 2027. Now let's look at what Yole shows for typical automobiles. This is a 2021. At that time, MEMS and sensors were 10% of the revenue for electronic content in cars. So already sensors play a big role. It's a 10% factor when you're breaking down the cost of automotive semiconductors. Inertial sensors. That's another legacy sensor suite for safety, for navigation, dead reckoning if you lose GPS. So those are all going to be needed for ADAS as well. Now, ADAS sensors for seeing, and by seeing, again, I mean radar, camera, LiDAR. You're seeing, this is just kind of a table showing the trends and showing the progression from level L2, level L3, and level L4, and how many cameras you're going to need. You're going to go from 5 to maybe 15 cameras per vehicle. LiDAR is going to kick in maybe level 3, certainly level 4, starting with one LiDAR system, maybe going up to 5 or more. And then radar is going to be implemented as well, because we want to have redundant seeing options depending on the environment, the weather, fog, night, etc. You got to have redundant and multiple technologies to sense things around the vehicle. CMOS imaging sensor trends. Again, CMOS imaging sensors uses legacy foundries, but they are doing some interesting technology add-ons. An example of that is adding germanium into the process to expand the infrared imaging band for these devices. So it's not just going to be what you would call traditional optical camera imaging. It's going to be infrared imaging as well. Automotive growth rates are projected to be over 8%, so it's going to be a significant portion of the CMOS imaging sensor market. Pixel sizes. Those pixel sizes have progressively decreased over time. 2023, we're basically in the 22 nanometer CMOS foundry node, which again is considered mature. It's on the low end. I mean, it's pretty advanced mature nodes, but it's certainly capable of what many foundries can produce. And really, maybe by 2025, it might get down to 17 nanometers. But again, it's not leading edge. It's somewhat trailing edge foundry technology. Infrared sensors. Originally, infrared sensors and infrared arrays were packaged in hermetic Kovar or ceramic packages, which is shown on the left here. The size and capability of these sensors and packages have gone down over time. They've had to improve anti-reflective coating. In some cases, there's filters there if you're trying to filter out certain wavelengths, and packaging is always a challenge. The goal there being chip scale packaging, maybe MEMS-based chip scale packaging where you do wafer-to-wafer bonding to form your chip scale package, and then solder bumps. Another trend that is related to CMOS imaging and infrared sensors is the use of optical image stabilization. This reduces the impact of vibrations and impact on image clarity. Without OIS or optical image stabilization, you'll get blurry pictures. Now, the traditional technique that's been used initially, particularly with smartphones, was just monitoring motion using inertial sensors and software. This has been enhanced with an actual optical image stabilization module that's electromagnetic. It's shown on the bottom left. This has been improved upon by MEMS technology, providing capacitive MEMS optical image stabilization platforms. An example of that is shown on the far right by Silicon Dynamics. Silicon Dynamics has taken this a step further and actually incorporated autofocus features on this chip, in which the CMOS imaging sensor is actually placed on a platform that has both optical image stabilization and autofocus features. Now, one of the things that I think is really very interesting, I've heard the term sensor fusion for over 20 years. It never really took off with legacy automotive manufacturers, and the reason for that is about 20 years ago, when they started talking about sensor fusion, they also started outsourcing their sensor modules. So one of the problems companies like General Motors, Ford, Toyota, VW have is they have all these suppliers with all these different software packages, and it's really difficult to integrate those together and talk to each other. Now, the advantages of these new EV manufacturers are they're starting from the ground up. Companies like Tesla, BYD, etc. Tesla's often said that their EV is just basically a software platform. So they can tweak the software anywhere because they're vertically integrated. And so that really made sensor fusion possible. So when you think of EVs as a great platform for sensor fusion, think of them as a vertical integrated, no difficulties in talking with sensor modules, and I think that data can be shared and it can be supplemented with artificial intelligence, which just recently has been put in the field. So we've got artificial intelligence, we have the EV vertical integrated platform. We're really going to see sensor fusion take off to kind of reduce the number of sensors needed. So last section, sensor supply chain issues. And there are issues, not just with just semiconductors, et cetera, but just sensors themselves. And a lot of them have to do with export controls. So the US has export controls on sensors. They've had that for years. Now they have it with semiconductors. There are real penalties, $100 million penalties if you violate this. They tend to revolve around infrared sensors, gyroscopes, accelerometers. So those are the three areas that traditionally have had controls. And as we go to ADAS, the IMU, the gyros have to be better and better functioning, better performance. And that's where you start overlapping with military applications, and you're going to encounter export control barriers. Most recently in the headlines, we've seen the export controls on germanium and gallium from China. So the reason that's significant for my talk is that those are critical material for infrared devices, not as well as power devices. So germanium, key for infrared sensing. Germanium and gallium are key for lasers as well. So there's a big potential impact there with regard to LiDAR and night vision systems from this export control. So in summary, I've talked about a number of automotive sensor trends. ADAS, autonomous driving, autonomous vehicles are increasing in adoption as we see the move towards electric vehicles. These sensors include LiDAR, CMOS imaging sensors, infrared sensors, ultrasonic sensors, a variety of inertial measurement devices, and new piezoelectric materials. Legacy automakers, with their outsourcing business model, were really slow to adopt these types of technologies, particularly when you compare them to electric vehicle manufacturers. The EV manufacturers and the EV platform has been treated like a single software platform. This enables both incorporation of AI technology and sensor fusion. Sensor fusion has been elusive for legacy automakers, but sensor fusion is certainly a possibility now with the electric vehicle platform. Sensor supply chains are also involved in some of the trends we're going to see in the future. This trend towards regional and national supply chain is going to have a big impact. Export controls could have a big impact on what sensors are available worldwide. It's interesting to note that China is in a very good position to dominate the L4 and L5 ADAS and autonomous vehicles through EVs and through their commanding development of the LiDAR supply chain. They're also leveraging the sourcing and the manufacturing of gallium and germanium, two materials which are critical for both electric vehicle power and a variety of infrared sensors for future automobiles. Thank you.